Okay, welcome back. Today is Saturday here in Scotland. It is vlog number 6. It is becoming less about vlogging because I'm not really telling you much about my life. But today, let's start with that. But before we get into it, if you like what you hear, give it a like. If you want to know when I'm releasing more videos, subscribe, hit the notification bell, and welcome to something about math or anything about my life, whatever decides to pop into my head while I'm talking. I think my big thing that I've been thinking about today is the big thing that I've been thinking about is probability. And we've talked about numbers and discrete, continuous, etc. But I wanted to pose a question and just make a shorter video today. But suppose you had a sphere. Now let's just imagine the Earth is the sphere. Now, for those of you that are skeptical about the shape of the Earth, there's not much I can do, but I guess pop out onto space and have a look. I'm pretty sure it's going to be round-esque. It's not a perfect sphere though, because of course you've got mountains and rivers, you got all these shapes, and it's also a bit squatter, I think, around the equator. So yeah, let's call it a sphere. But anyways, let's say you took any 3 randomly selected points, or in this case, latitudes and longitudes, and we can include the altitude, but for the purpose of this, let's just say the Earth is a perfect sphere. There are no hills, there are no rivers, it's just perfectly round and smooth. And let's say you just took 3 random points. What is the probability that you will be in one hemisphere? Now, don't think that I mean just the hemisphere of the equator. I mean any line or any plane that you will cut through the Earth that gives you 2 equal half spheres. So it could be the hemisphere that goes from the North Pole to the South Pole, or across the equator, or 45 degrees down to 45, 90, 135, 215. I think it's 215. Yeah, 180 plus 45 is 215. So 45, 215. Any 3 randomly selected points, what is the probability that those 3 points will be on the same hemisphere? I won't answer that today. I'll leave that as something to think about for tomorrow, and I'll answer it then. I think when you think about it, it's easy, or at least when you see the answer and you see a reasoning behind it, it's easy. But at the same time, I think this is the thing with probability, or statistics for that matter, is it's understanding the information around the topic and then trying to see through it. So for example, there was a question that I read in a Gartner book about mathematics. It said that, let's suppose you and your partner you've played 4 rounds of bridge. So I'll stop there. I've never played bridge, and I don't know the rules. I don't know how many decks you have. So if you're playing bridge, the question is after 4 rounds of bridge, what is more likely, that you will have 4 clubs or your partner will have no clubs? And to think about that question, first off, you should understand how many decks of cards are there in bridge, because let's say you had 2 decks, and I didn't know that, but you didn't know that, so you couldn't give a proper answer to the question because you don't know the information surrounding that question. And in modeling, that's the point, is you have some sort of situation you're thinking about that you want to come up with a numerical answer for. Well, you need to know the situation. You need to know what's going on. So I'm going to leave it with that short vlog today about the 3 points on the sphere. What's the probability that 3 points at random will be in the same hemisphere? We'll talk about that tomorrow, and we'll talk more about sort of enumeration, what's called combinatorics. You're looking at different possibilities of things. So for example, another question is, how many different ways can you can you arrange three coins? You know, like one of the ways would be heads, heads, heads. So how many different combinations are there for 3 coins where each coin is two-sided? And then what's the underlying mathematics behind that? Because you could do it with 3 coins, you could count it out, and you could give every combination, and then you could count how many combinations you have. Or let's say you had 400 coins, and you're like, well, how many different ways can I arrange 400 coins? And what's, you know, is there some sort of computation, something I could crunch into a calculator or do by hand to figure that out? So we'll chat about that tomorrow. I'm going to leave it with that. Thank you so much for joining in. I know sometimes I have a slightly longer video, but today, shorter video just to say hi and wish everyone well. All right, peace. Bye.